Okay, section 4.7, solving linear equations using graphs. So tonight we're going to be doing something a little bit new. Usually when we solve equations, we think back to maybe like chapter 3 stuff where we had one-step equations, multi-step equations, equations with variables on both sides, and you learned how to solve for x. And that's sort of an algebraic method. But there's also a graphing approach that allows you to solve equations. And this is going to seem a little weird at first, but just kind of keep an open mind and hang with me. It'll all make sense by the end. So it says, so far we have solved equations algebraically. Now we will look at solving them graphically. So how do we go about doing this graphically? Well, almost anything we do in algebra can be represented on the coordinate plane. It's always a good connection to make in your mind. How would this appear if I were graphing it? Okay. All right, so to take an equation and solve it graphically, we're going to follow a couple of different steps. Okay, the first is to write the equation in the form ax plus b equals 0. I don't expect you to really remember it that way, but just think about it like this. You have something times x, ax, plus or minus some number, some loner. You basically want to get all that stuff on one side set equal to 0. So whatever the equation looks like, get all of the stuff, all of the x stuff, all of the loner stuff, get it all on one side, set equal to 0. In your second step, you're going to take that 0 and basically you're going to change it to y. Okay? To graph something on the coordinate plane, we need an x and a y. Usually with an equation, we just start with just an x. A linear equation is just going to have an x. Okay? So get everything set equal to 0 and change that 0 to y, and you'll have something that looks like y equals mx plus b. Okay, so you'll be putting something in slope-intercept form. And instead of using a 0, you're just going to plug a little y in there. And that's going to allow you to graph it, because you already know how to graph y equals mx plus b. So you're going to do the quick graph that we did in the last lesson. Start with your y-intercept and then use your slope to plot your other points. And then once you get your graph, your solution is actually located somewhere on the graph, and we're going to see that wherever that graph crosses the x-axis, okay, that is the x-intercept, that's going to be where your solution is located. Okay, feel free to come back and listen to this if you need to, but we're just going to hop right in. And you don't need to do anything yet other than just kind of listen to me right now. You do want to have out graphing paper tonight, but you don't have to write anything down just yet. So what we're going to do is we are going to look at this equation here, negative x minus 3 equals 1/2 x. And we are going to solve it algebraically first, okay, just to review things that we did back in chapter 3. Okay, so if we were going to solve this equation algebraically, remember we talked about collecting the x variables. So we have variables on both sides. Most of us would probably want to stay in positive land, so we might add x to both sides. Don't let that fraction throw you. Okay, so the x's on the left cancel out. You're left with negative 3. Okay, and then we have 1/2 x plus x, or 1/2 x plus 1x perhaps. So most of you, might think of that as 1 and 1/2 x. No one really writes it this way though. Remember, we don't want to involve mixed numbers. We really like having those improper fractions because they're a little bit more, when you have a fractional coefficient, it's a little bit more like the slope. So remember, 1 and 1/2 is the same as 3/2. So I prefer to use the mixed numbers. Okay, so 1/2 x plus x is going to be 3/2 x. And then what do we do from here? Well, we've got to get rid of that 3/2. So remember, we would multiply by the reciprocal. So we'd multiply by 2/3 on both sides. Maybe put that negative 3 over 1, if that makes you feel a little bit better. And then you're going to have a lot of canceling out here on the right-hand side. 2's cancel, 3 cancel, you're left with x. And then on the left-hand side, 2 times negative 3 is negative 6, and 3 times 1 on the bottom is 3. Okay, so negative 6 divided by 3 is what number? It's negative 2. So when we solve this, we get negative 2 for x. And that's a question I could have given you on like a quiz or test from chapter 3. So just kind of keep that in the back of your mind. When we solve this equation, we get negative 2 for x. This is the algebraic way. Okay, we're going to eventually look at it graphing. Okay, so just to kind of sum up, We collected x variables and got 3/2 x on the right, and then we multiplied both sides by 2/3, and we ended up with x equals -2. Okay, just kind of file that away. All right, that's algebraically. What if we wanted to do it graphically? Okay, so same equation, -x minus 3 equals 1/2 x. If we want to do this graphically, we are going to have to get everything on one side set equal to what? Okay, set equal to 0. That's sort of our goal. Okay, and there are a couple different ways we can do this. Some of you guys might subtract 1/2 x, and we could get -3/2 x minus 3 equals 0. If you want to stay in positive land, we might begin by adding x. And this is reminiscent of what we just did solving algebraically. It's going to have a twist to it though. So we get the -3 equals 3/2 x. But we're not going to stop there. Remember, our goal when graphing is to get everything on the same side set equal to 0. So now I'm going to add 3 to get rid of that -3 on the right. I'm sorry, to get rid of that -3 on the left. So I've canceled all the stuff out on the left, and only 0 is left behind. So 0 equals, I'm going to write my x stuff first, and then my constant in the back. 0 equals 3/2 x plus 3. Okay, that's step 1, getting everything on one side set equal to 0. Step 2, remember we're going to change this 0 to what? We're going to change it to y. We get y equals 3/2 x plus 3. That's something that you can graph, okay, and you already know how to do that. You're going to start at +3 on the y-axis, that's your y-intercept, right? And then you're going to go up 3 over 2 using your knowledge of slope to kind of graph that line. Okay, so quick review. We want to write it in the form where we get everything on one side set equal to 0. So 3/2 x plus 3 equals 0 when you manipulate that algebraically. And then just change the 0 to y. And that's going to give you something in slope-intercept form, y equals mx plus b. Let's see what happens when we graph this thing. Okay, so remember we're going to start with the +3 on the y-axis. That's the point right there. Okay, that's your y-intercept. The slope is 3/2, so we're going to go up 3 over 2, and then up 3 over 2, and that gives you a good idea where your line is going to be. Okay, now take a look at the graph. Okay, hopefully you kind of remembered in the back of your head, what was the answer we got when we solved it algebraically? Okay, the answer we had was x equals -2. Or I think we had it written as -2 equals x. They both mean the same thing. Where do you find that answer on the graph? Well, remember, if you follow the graph and see where it crosses the x-axis, that is going to be the location of your solution. And so that is what we are getting at. Okay, so x equals -2 is actually encoded in the graph itself. That shows you where the solution is. And so the main idea of today's lesson is that the solution is the x-intercept, or it's located at the x-intercept. Okay, and that's pretty much it. All right, go ahead and get out your graph paper. We're going to go through one of these together, and then I'm going to give you 2 to practice on your own. Okay, so if you need a little time, you need to set up a coordinate plane right now, just a quick coordinate plane. The equation we're going to be looking at is 3x equals 6 plus x. So if I were you, I'd begin by writing that equation down, and then kind of set up 2 halves to your page. On the left side, maybe write solve algebraically. On the right side, write solve graphically, and just draw a quick coordinate plane underneath. And then we're going to go through and do both of these things. Okay, let's begin with the solve graphically. We're going to go in a different order than what we just worked with. Okay, so to solve graphically, you're still going to need a little space to put this thing in slope-intercept form. So go ahead and begin by copying down 3x equals 6 plus x. And then what are we going to do here? Well, we want to get everything on one side set equal to 0. And so, you know, that 0 is either going to end up on the left or it's going to end up on the right. There are two different ways you could actually do this. To me, the easiest way right now is to take away 3x. So if you want to do it my way, you can do it that way. If you wanted to subtract the x from the right side and then subtract the 6, believe it or not, you could also do it that way. You're going to end up with the same answer eventually. Okay, after I take away the 3x, I'm left with 0 equals, and I like to put the x stuff up front. So x minus 3x is negative 2x, and that 6 is a positive 6. And then remember, we're going to take that 0 and change it to y. So y equals negative 2x plus 6 is what we are going to be graphing. Okay, now remember I told you that you could have gone a different direction at the beginning. You could have subtracted, for example, you could have subtracted x, and you would have ended up with positive 2x on the left, and then you could have subtracted 6, and you would have ended up with a negative 6 on the left. So if you had gone that direction, you actually would have received a different equation. And I'm telling you this so that you don't freak out on your homework if you get a different answer than I do. You could also receive y equals 2x minus 6. It's basically the opposite of the equation we just came up with. Okay, so if you got that equation, it will also work. But I'm going to go back to my original one, negative 2x plus 6, and let's go ahead and graph this guy. So it starts with 6 on the y-axis. So you want to put a point for your y-intercept. And then my slope is negative 2, so remember that's negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, until I get as many points as I feel comfortable with. And then you want to go ahead and connect and create your line. So that's your graph. Okay, remember the whole point to what we're doing is we're trying to find the solution on the graph. So where is the solution? Well, it's the x-intercept. What is the x-intercept here? It's this point. And on the x-axis, that's 1, 2, 3. So what I'm looking at here is x equals 3. That is my solution. Now I do want to point out, had we gone the other way and had you ended up with this equation, you're going to get the same answer. Okay? If you graph 2x minus 6, you're just starting off at a different place. 1, 2, 3, 4, 5, negative 6. You're starting off here, and then you're going up 2 over 1 because it's a positive slope, right? And you're basically going to get a similarly sloped line, but this one is a positive slope instead of a negative slope. Okay, so it's kind of like an opposing line, but the whole point is it still goes through the same x-intercept. So you're going to get the same solution no matter what. So you only need one of these lines. All right, now let's solve it algebraically and make sure that our answers match up. So on your other column, go ahead and recopy that equation. 3x equals 6 plus x. And then what would you do first to solve this algebraically? Okay, don't get confused. When we solve algebraically, we want to get x's on the same side so that they're kind of opposing a number, and that's going to allow us to solve. So here I get 2x equals 6. So notice how the x is opposed to the loner, which is on the other side. Okay. To isolate the x, I'm going to divide by 2, and I come up with x equals 3. How do I know that that's what I am searching for? Well, the algebra and the graphing should be the exact same. In other words, you should have the exact same answer there because, you know, the coordinate plane is just there to support what's going on algebraically. So that's the point. Whatever we can do algebraically, we can also represent graphically, and you're learning that the solution is located at the x-intercept of the graph. Awesome. All right, hopefully that wasn't too overwhelming. I want you to try one completely on your own. Okay, so this is the one I want you to look at. Negative 3x minus 12 equals negative 5x. Go ahead and solve it graphically first, right? Put it in slope-intercept form, get everything on one side set equal to 0, change that 0 to y. See where that graph is headed, see where it crosses the x-axis. That's going to be your solution. And then do the algebraic rendering to see what you get for x, and those two should match up. And if they do, you should feel pretty good about yourself. And if they don't, I'm going to go over it, and then we can learn from our mistakes. So go ahead and do this on your own first. Hit pause now, and then unpause when you're ready to go over answers. Okay, let's go ahead and see how you did. And I'm just going to ask for you to be patient as I go through this. And you just want to see if, you know, what I'm doing is matching up and is similar to what you did, or if there are differences, to see if those differences are allowed. Are we ending up with the same answer, or did you go down a wrong path? So I'm trying to do this so you can kind of learn from your mistakes. So I'm going to start with the graphically first. And remember, for graphically, I want to get everything on the same side set equal to 0. And so for me, the quickest way to do that is to add 5x. I realize that some of you might not have done that. Some of you might have added 3x. You're not necessarily wrong. Okay, we could all end up with the same solution eventually. Okay, so that's going to give me 2x minus 12 equals 0. And remember, I'm going to change 0 to y. I'm going to take that 0 and turn it into a y equals 2x minus 12. Now, I also know in the back of my head that the opposite of this equation is going to be true. So if you had added 3x to begin with, and then you would have added 12 over, some of you may have ended up with y equals negative 2x plus 12. And if you ended up with that equation, you're also going to turn out, hopefully, with the correct answer as well, as long as you graph it right. So both of those are acceptable. There are always going to be two possibilities whenever we're solving graphically with these linear equations. All right, let's do the 2x minus 12. I'm going to go back to my original one. I believe negative 12 is all the way down here. Okay, so that's my y-intercept. That's where I'm beginning. And then I'm going up 2 over 1. Oops. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. You can kind of keep going. So that's where my line ends up. I'm not sure if you had the same line or not. Hopefully, if you were using that equation, you did. So where does this suggest that the solution is? Well, wherever the x-intercept is. So this point right here. And that's at 1, 2, 3, 4, 5, 6. So I'm looking at x equals 6. If you had the other equation, okay, in case you had a negative 2x plus 12, you started up here. Okay, you started up here for your y-intercept. And you had a slope of negative 2, so you went down 2 over 1, down 2 over 1, down 2 over 1, so on and so forth. Okay, your line should have intersected the x-axis in the exact same place. So as long as you had one of these two lines, you came up with the right solution. And I'm not, entirely convinced that that's right, but I'm going to back it up algebraically. Okay, so now I'm going to move on to the algebraic part. I recopy my equation, negative 3x minus 12 equals negative 5x. Okay, and here I'm going to add 3x to both sides. And this is going to give me opposing values. So I have a negative 12 on the left, and I'm opposing that to a negative 2x on the right. And then I'll just divide by negative 2. And that gives me x equals positive 6. And as long as that matches up with what I get graphically, I can feel pretty good about myself. Hopefully you feel pretty good about yourself. Let's move on. All right, last one. This one also has variables on both sides, slightly more complex. Same deal, I want you to solve it graphically first, and then come back and back it up with the algebra, and hopefully you get the same answer for both. Go ahead and do this one on your own, and then unpause when you're ready to go over answers. Go ahead and hit pause now. Okay, let's see how we did. Hopefully you're looking at the same answer for both of these, and that would be really awesome. I'm just going to recopy this really quickly. 3x plus 6 equals negative 2x minus 4. And this is where we might disagree. We could either subtract 3x or add 2x, and it really doesn't matter either way. I taught you guys to collect variables and keep everything positive, so I'm hoping that most of you added 2x. Just to mix it up, I'm going to subtract 3x. So maybe I'm doing something different than what you did, and that's okay. And you're left with 6 equals, that looks like negative 5x minus 4. And remember, I'm trying to get everything on the same side set equal to 0. So now I need to take away my 6. A little bit different than solving algebraically. And this leaves me with 0 equals negative 5x. And that's a get mug twice. You lose 4, you lose 6, you've lost 10. So 0 equals negative 5x minus 10. Change my 0 to y. And I should have y equals negative 5x minus 10. So that's the equation I'm going to roll with. Some of you guys may have had y equals positive 5x plus 10. And that's okay as well. Your line's just going to look a little bit different than mine, but they should share the same y-intercept. All right, let me come down to negative 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my y-intercept. And it says I have a slope of negative 5. And usually I write that as negative 5 over 1. The problem here is I can't go down 5 because I'm out of room personally. So I'm going to write the inverse of this, 5 over negative 1. Okay, so I'm going to go up 5, 1, 2, 3, 4, 5, but then to the left 1. And that will also be on the same line. So up 5, 1, 2, 3, 4, 5, over 1 to the left. Left is considered the negative direction here. 1, 2, 3, 4, 5, over 1. So those are the points I'm getting for my line. And let's see what happens here. I'm going to go ahead and connect these guys. Of course, I can already tell where this is crossing the x-axis. You can see that information right here. So what is that point? So it looks like we have x equals negative 2. That should be my solution. If you went with y equals 5x plus 10, okay, then you're going to have something that's going up the roller coaster like this, and it's also going to cross at the same place. Okay. All right, so I got x equals negative 2. Let me go back to the algebraic process now and see if I can come up with the same answer. And if I do, then I can feel pretty good about my graphing. 3x plus 6 equals negative 2x minus 4. Now this time I am going to collect variables and keep things positive. So I end up with 5x plus 6 equals negative 4. And remember, I'm trying to oppose my variable with some number. So I'm going to subtract 6 so I can have something on the right to play with this stuff. I get 5x equals negative 10. Right? And then I just divide both sides by 5. Negative 10 divided by 5 does give me the negative 2. So whether it's algebraically or graphically, I'm getting the same answer. Okay, and this is a really important concept. It works with all types of graphs, and we'll delve into this deeper throughout the year because we won't always be doing linear things. Eventually we're going to get into parabolas and some some nonlinear graphs. So knowing that where your graph crosses either the x-axis or y-axis, it does kind of carry some meaning to it. All right, good job with this. I think if you got this, you'll do really well on the assignment. The assignment will probably be pretty easy for you, and I will see you next class.